So in this tutorial, we're going to be doing experiment M5. So from our question, experiment M5 is oscillating loaded cantilever 2. So we are going to use it to determine the period of the oscillation of an oscillating cantilever and the weight of the said cantilever. So these are our questions. First thing, one of them, every question is here. Just follow it step by step for each process. Then when you come to IS, plot a graph of t square on the vertical axis against m on the horizontal axis. So first of all, you're going to have your table of values. So this is your table of values. You have your march, your time, your average, your period, and period square, t square. So your table of values may not be exactly as mine, but get something related, something workable. So we're working with t square against m. So the least number in t square is 0.06, right? And the least number in m, that's mass, is 0.000. So we're going to plot our graph using this. So now when we come to this place, we have for our x-axis, we have mass, that's 0.000 and 0.050 and 0.100. So we are doing our m-axis. In our m-axis, we have 2 cm is to 0.050 kilogram. So each of the 2 cm is 0.05 cm kilogram. Then for our t square axis is 2 cm is to be 0.050 seconds. So it's still the same thing for both axes. So this is 0.050, 0.100. So we're using the same unit for the both axes. So now our first this thing is 0 is to 0.0650. So now to achieve this thing, our 0 is here, but to achieve our 0.065, see, if you want to know all these tiny lines what they are, do 0.050 divided by 10. When you do, because each of these lines are 10, so you want to know what each line will give us. So when you do 0.050 divided by 10, you get 0.005. So it means that each of these line is 0.005. So when you do 0.050 plus 0.005, it will give you what this line is. What you get this when you add 0.0005, it will give you what this line is. When you add it, when you get it, you add your 0.0005 to this one. So this is what you continue to do. So along this side is my 0.065. So this is what you continue to do till you get every of your points. So just read it carefully. That's what you're going to do till you get every of your point. Then the next question is, we should determine, after getting your plotting your t square against your m on horizontal axis, determine the slope of the graph. And remember, slope of the graph can only be gotten after you plot your graph, right? So this is our M5. So remember the rules of plotting. Like when the lines join, the remaining lines should separate themselves and be on different sides. So now we have, this is 7 points, these are 7 points and 3 joined. So we have 3 here and 1 here. So our slope is determined by this. Your t square 2 is, you calculate this particular one, or you use it based on your point. This 0.300, right? Under 0.30 we have 0.3283. So that's what I read, 0.3283 minus our t1 is this, our third point. So we come to our third point. Our third point is 0.1176. So 0.3283 minus 0.1176 over our mass is 0.300 minus 0.100. So that's what you're going to do to be able to get your slope. After you get your slope, it may not be exactly like this because we may not have the same figure of table of values. So after getting this, after getting this, we are asked to evaluate 4 pi square over x. So where your pi is 22/7, right? So now this is your formula. Your pi is 22/7, which is the same thing as 3.14. Then the other numbers. So if you do your 3.14 raised to the power 2 times 4 all divided by your slope, you get your k. Then the next question says solve k in f equal to ks and compare the result with question si. So now f is equal to ks, right? F is equal to ks. And also we are going to introduce something else. F is equal to mg. Mg is because F is ordinarily equal to ma, acceleration due to gravity. But then we're using g because it's due to gravity. F is equal to F. So when F is equal to F, ks is equal to mg. So now we're looking for our mass is 178 gram. That's mass of a ruler, standard mass. Our g, gravity 9.8, then x is 35. How I got this 35? If you look at your question said using the second ruler measure a fixed distance down of 35 centimeters. So when we're changing it to meter because we are working with meter, so 35 centimeter divided by 100 is going to give us 0.35 meter. So we're going to introduce this formula. This formula is gotten by making k the subject of the formula, then mg over x. So mg over x is going to give us 178 times 9.8 all over 0.35. That is going to give us our k, right? Then the next question says we should compare the results with xi. Xi is this and SII is this. So our SI we got k as 37.5. Then this one we got k as 4984. So to compare, it means that the cantilever with k equal to 4984 is much stiffer and oscillates with a higher frequency than the cantilever with k. So you can also browse this particular question. It means that this one with this higher frequency moves faster, like it has a higher frequency. This one with 4984 has a higher frequency than the other one. So the next question says we skipped SII and SIV, right? So state two precautions to ensure accurate results. We can browse about precaution needed for working in an oscillating depth cantilever. The one I got, I read keys at eye level to avoid parallax error. Like when reading your scale on the table, you read at eye level to avoid parallax error. Then I ensure that the G clamp was firmly fixed to avoid injury that might be caused by the fall of the clamp. So you can also browse more precautions and get it right, put a reason behind it. So I've come to the end of this tutorial. Hope you enjoyed it. Thank you.